Good morning. Well, I mean, it might be, I don't know. Good morning, ladies and gentlemen. How are we doing today? Fine. And it's now early release day for you. Woo-hoo! What we should have done on Tuesday, ladies and gentlemen. Isha, let's go.
Oh, yeah.
Oh, yeah. Oh, yeah. Excellent, excellent, excellent. Okay. So, you may not need it on this problem here. Tell me what constant inverse relationship would look like on a graph. So what does the line look like? So you tell me what constant means and then what inverse means. There's a shape for each. Then tell me what a non-constant and direct relationship is.
God bless you.
Look at this graph here and tell me what is held constant. These ones that are square boxes means you can check more than one of them. Okay? You may only need to check one. You can check more than one correct answer. And the ovals mean only one correct answer.
Correct.
There you go. There you go. Come on back over. Hey, again, no guidance counselors allowed out here. Hold on. Here you go. What? Okay. How are we doing, ladies and gentlemen? Wonderful, wonderful, wonderful. Hey, those electronic devices that aren't a computer, put them away. That doesn't help, Levi. Take out your computers. Bless you many times. Okay? All right, ladies and gentlemen. You brave souls who decided to come out on this non-snowy, non-terrible, pretty nice morning, actually. So, dang what?
Nothing.
It doesn't matter if you would have answered the one question, you might have gotten more.
Which one?
The one at the top of the second column.
Oh, I forgot. I didn't even see that.
So what's the constant there?
No, which one?
The graph, the picture of the graph.
Oh.
Cynthia's going to tell you how.
It's the slope. Is it? I don't know.
Cynthia, tell her what the answer is.
For which one? I don't know. I got a 13 on it. Remember? You told everybody.
13's good. It's out of 14.
It was out of 14.
Oh.
Cynthia, tell her what the answer to that one is.
For which one?
This one.
The graph.
Dang, you should have reminded me when I handed it to you. Did you forget this one?
I can't read that.
Cynthia.
What is L?
No.
You're the one who called me over and said, is it really this simple on that question?
Constant math. It's right there.
That's my answer. Give me that point. Do I need to keep it?
Yeah, I'm done with it. I don't need it anymore. I got the grade in and everything. So, you're welcome. You're welcome. You're welcome. By the way, ladies and gentlemen, again, in case you weren't here, on the board is your schedule for today. So that is the way the classes will go. Straight 1 through 5, no home base, lunch hour at the end of the day. So if you want to leave for lunch or if you want to go home at 12:25, you are welcome to, ladies and gentlemen. Okay? Questions? All lefty then, ladies and gentlemen. Dun, dun, dun. Let's get some attendance. Okay.
Future Brinley and then future brother.
Yeah, you do that. You gotta do that. You just keep saying this. I know.
I know, that's why, guys, it was literally why I got a smaller backpack, because I don't need a giant backpack.
What are we doing?
Are you gonna use this every day now?
Yeah, why would I buy it if
I didn't know you just bought it. I thought you had it.
No, I just got it.
Well, that's
So, what's the topic of discussion? Brinley's backpack? What's wrong with her
She got a
backpack?
little bag, and everything from her
So, Graham, why
backpack
you
fits in
so
a
nosy?
little tiny bag.
Why are we talking about it in class? I'm not part of the class now, Cynthia. I don't get to get in on these conversations.
No, that's like saying the president is part of the citizens.
Dang.
It's not the same
You
thing.
ate that up, Levi. You're so smart.
What?
You ate that up.
How is that not the same thing?
It's like you're like the president.
No, I'm
We're
not.
the people.
I'm smart.
Can't vote for himself.
I'm not like the president. I
Did
can't
you-
vote for
Did you
myself.
say you are smart? Or you-
Yes.
That's a good point.
Let's rethink that.
Okay.
Fine.
Smart enough not to be a politician.
Yeah.
So,
You're kind of the age though.
Like Joe Biden. Joe Biden.
That's crazy.
no, not Joe Biden age.
Oh,
But yeah, you're right. We elect a lot of old people to lead our
Literally,
country.
Mr. Nelson told me to
Joe
say that.
Biden isn't even politician age. He's over
Mr.
politician.
Bragg.
Yeah.
What's Mr. Michael? What's Michelson's first name?
Mister.
Mister,
Oh, that was really good, guys.
Why?
That was really funny.
So,
why don't you ask him?
That made me laugh.
By the way, you can look up any teacher's first name. My
Was
gosh,
that being stupid?
last trimester they found my address in like 30 seconds.
What the
So-
hell? I ate that up.
So, you guys are the Google generation. Google it. Figure it out.
Oh yeah.
Wait, do you think he's on LinkedIn?
So like my father.
Do I think
You
he's
have
on
easy
LinkedIn? I don't even know what LinkedIn
You
is.
do you know what?
I had to read a textbook.
All right.
Okay.
Today, ladies and gentlemen,
Congrats.
we are going to do our lab today. We'll get that done, out of the way, finished up. Remember on Monday we got a quiz. So be ready for that on Monday. Atomic structure will not be on the quiz, the stuff that we started yesterday. Actually, let me double check just to make sure, ladies and gentlemen. Classification. Oh, I guess atomic structure is on there. Ooh, holy cow, good thing we got through it.
M-A.
Oh, here he is.
Did you find him? Did you find him? Did you find him? Is he on LinkedIn?
We're gonna find out.
Vote for Matt.
Who?
What?
Matthew Michelson.
Oh.
Huh?
Okay.
He ran for office.
He ran for office? What office?
Yeah, I remember
Yeah.
he was going to be the president of the United States of America.
Well,
Heat,
that-
temperature, KMT,
What is KMT?
kinetic molecular theory,
There's a guy named Bob Michaels.
classification of matter.
He's a photographer in Greater Boston.
So atomic structure is not on the quiz, ladies and gentlemen, but classification of matter, heat and temperature and the differences between them, and kinetic molecular theory are on the quiz on Tuesday, because you got a 3-day weekend coming up. That's right, ladies and gentlemen.
Week coming up.
And you have a 3-day week coming up,
And
which
a
means then
4-day
you have a
weekend.
4-day weekend. Then, oh my gosh, you're going to have to put in 4 full days of school unless we get a snow day in there. So, all right. Tell me something about the structure of an atom. If you go first, you get all the choices. Has protons,
Has a neutron.
has neutrons,
Got electrons.
got electrons, covered the 3 basic. Good. Now you got the harder things.
There's the same number of protons and electrons in a neutrally charged atom.
Very good. Same number of protons and electrons in a neutrally charged atom. Really, what do you got? What's the matter?
Sorry.
Why are
I'm
you
paying
so-
attention.
Then we did that.
Really, then give me an answer.
Gosh darn it. I don't have any on top
We
of my
didn't do
head.
that
I'm
yet.
sorry.
Okay, then
Can
think
you
about
shut up? Sorry.
Really? In the last 30 seconds of conversation, you've apologized 30 times, and you have yet to give me an answer to name me anything about the structure of an atom.
Really go up.
I don't know.
Then look back at your notes. You got that computer thing in front of you.
Look,
Okay.
Get
Richard,
off of
Atom?
Rick Rock or whatever you're on and look up your
Is it of
notes.
neutrons?
anything
Wait,
in
shoot.
an atom.
Bang, bang, bang.
Why do I have
Just
to do
pick
it?
something and read it.
Okay. Okay,
And then they wonder why we went to
all-
71-minute classes. It was the
all
only way to get
atoms
anything done.
start out neutral.
Okay, all atoms start out neutral. Good. Christian, give me
I
something
was
about that.
I was gonna say in a charged atom. That's it.
You're looking at Aiden. Aiden's going to be looking at you because in a minute I'm going to call on Aiden.
Adam
I'm not
has
calling on
4
Cynthia till the end.
letters. Thanks. Boom.
Nice.
It was small.
You showed
Okay, they're small. I'll take that. Good. Aiden, now that he took yours, huh?
They're very small.
Hey. He already said that. Don't go.
No,
You
it's
said
very
they're
small.
small.
Extremely small.
0.111.
Great.
Something
So now they're smaller than extremely small. Okay, we could keep going around all day with this. Give me something, Aiden. What's the center part of an atom called, Aiden? Thank you, the nucleus. Jacqueline, give me something about an atom. I like that. She was casually sitting in the back. And when I called on her, she didn't give me the full eye roll. She just gave me kind of that, that little one. It was like, yeah, okay.
You should have went all the way.
I know. Should have. Never go halfway.
You're wasting.
I'm sorry. Hang on a minute because there were people talking up here and I couldn't hear you. Sorry.
It wasn't the atomic particles that they made up makes the atoms different from each other.
Okay, the subatomic particles that they make up make the atom different from one another. Good. Daniela.
Can I talk about a proton?
Sure, go ahead. Tell me about a proton.
It has a positive charge.
Okay, good. Well, do you know where it's located too?
No.
What? You found the charge, but you didn't find where it was located?
I'm just kidding. Ask them after this.
Okay, Jared, what do you got?
Electrons are in the electron cloud.
Okay, electrons are in the electron cloud. Cynthia!
Whoa.
Wait, what did she say? Electrons have what?
In the electron cloud. Please listen.
It
I
has
understand why you don't want to listen to me, but you should listen to your classmates. Except for Brinley, because she talks a lot.
Electrons have a negative charge.
Electrons have a negative charge. Very good, ladies and gentlemen. Those are the kind of things that won't be on your quiz next week.
Yeah.
Okay.
Okay.
Shake my head.
That was a
Oh,
great
next
test.
Tuesday.
Great review.
Yeah, you showed us.
Good. All right, ladies and gentlemen. So today, let's get our lab done.
Why?
Okay?
Or
Why?
we could not.
You're right, or we could not. So you just want to take a 0 on it?
Let's just have a potential energy lab where we think about what we could do, but we don't do it.
We think about our potential.
We think about our potential in life. Let's do that.
Yes, but I think you will be much better off if you actually do the lab and use some kinetic energy. So we're going to go with that because you have no reason to store up any more energy than you got. You're almost brimming with energy, Brinley. Almost. All right, ladies and gentlemen, go to Google Classroom and open up the aluminum and copper chloride lab that you will find there, ladies and gentlemen. This is what it looks like. We will determine if the steps in this lab represent a physical or a chemical change, and we will provide reasoning to support our decision. That is what you are going to do in the lab today, ladies and gentlemen. Okay? That is what you are going to do in the lab today. All right. Well, I go back and get the box for your goggles for those of you who got them. Those of you who didn't bring them, you'll be buying a pair for me today, ladies and gentlemen. You'll be putting your name on them, and then you'll be putting them in a box that you can keep here, or you can take with you. I don't really care. It doesn't really matter to me, ladies and gentlemen. Choice is 100% up to you. But this box right here that says 1 first hour, that's your box. So if you want to leave me your goggles, you can. At the end of the trimester, ladies and gentlemen, we will take and no idea who the C's are.
It's probably mine.
Yeah, it's probably yeah.
That'll be yours?
Yeah, I got mine like forever ago.
Okay. Well, I'm going to ask you to do this on the mural. Please put your name on it. When you please put your name on your goggles, don't put it across the front here, or I'll make you buy another pair. Red, blue, green, or black?
Red.
Red?
Red.
Boo.
No, not blue. Blue.
Shoot.
Oh,
Not
Hey.
again.
Can you pass me
Okay.
the blue one?
Can I pass you the blue one? Ready?
Yep.
Good catch. Good
thing
catch.
I'm not a quarterback.
I hit him in the hands. What more do you want?
I don't know. That was just kind of weird.
That was just kind of bad. You should never do that again.
Don't ever try that again.
Don't ever do it again.
Wait, I'm putting it on the band.
No, don't put it on the band.
band.
Put it around like on the top or on
Yeah,
the side
I put it
normally.
on the top.
Just don't write it on the front of your goggles where it interferes with what you're going to be able to see.
What to do.
Okay, so before you can probably identify chemical or physical changes, ladies and gentlemen, we should. What?
Who wrote it on the front that you have to say don't write it?
I was actually
Multiple
Do you know what's
freshmen
gonna
when
happen
I
is
used to have
I was actually
freshmen
gonna
use
write it on
them.
the front.
I believe it. I believe it. And that's why I tell you, don't do that.
Do you want the
I'm glad you told me. 'cause I
No,
was-
I'd like you to keep the marker forever. Yes, I'd like the marker back. It wasn't a one-way marker. Terrible pass. Okay? Okay, so here are some signs of a chemical change, that a chemical change has occurred, ladies and gentlemen. One of them is a change in energy. What does that mean?
Changed energy.
Good, you changed energy. Now, can we define that without using those 2 or 3 words?
you added or took away energy?
How will you know if you added or took away energy?
The temperature or something?
Okay, but we're not taking a thermometer out for today's lab.
Kinetic energy.
If it warms up,
Or
cools down.
Freezes.
cools down. Doesn't necessarily have to freeze. Doesn't necessarily have to boil. But it means that if energy is given off and you can feel heat,
You said it.
or if it feels cold on your hand, if it feels cold on your hand, what does that mean for energy? No, it's actually,
It wouldn't be no.
if it feels cold in your hand, the reaction is doing what with energy? Using it or taking it in, taking it away from your hand. If it feels hot in your hand, what does that mean?
It's giving off.
That it's giving off energy. So that's the 2 ways that energy can go. It can either be given off or it can be taken in. So if it is taken in, it will feel cold in your hand. If it is given off, it will feel warm in your hand. Is that the only kind of energy that you can have in a reaction?
Yeah.
No.
You could throw it on fire.
Yeah, it could start on fire. Sure. Okay.
Couldn't it just not have the
It could fall.
Okay. But again, that's potential energy. You drop it. I'm talking about the reaction actually releasing energy. We said it could release heat. We said it could take in heat. What is the other form of energy that some reactions release? What?
Yeah.
But that's not energy. You are right, though. They can release a gas. That is true. Think of 4th of July. People run around with these necklaces.
They explode.
What?
Nice.
Spark.
No, they don't run around with a spark
They
necklace.
glow.
Glowing.
Glow, glow,
neon.
Glow,
Light.
glow sticks. The glow lights. The ones
Oh,
that you
shoot.
can take and make a necklace out of. The
Gosh,
ones that
darn
go, what the heck is going on?
Shoot. Shoot. I got
How do you
excited.
start a glow stick?
You break
Crack it.
You break it or you crack it. Why?
Ran it.
Why?
Because that makes a chemical reaction.
Yeah.
crazy.
There inside the glow stick there is a container with a second chemical in it. There is a liquid chemical in there, but you crack it so that the 2 chemicals start mixing. When they mix, they start giving off light. Now, that is a change in energy, even though it may not necessarily be heat given off or heat taken in. Light could also be given off. Cynthia pointed out, too, that a gas could be released. How do we recognize a gas being released? We can see gases.
You smell it?
We might smell it. Good. When can we see a gas being released?
When it's cold.
What?
Bubbling.
When we see bubbling. So you're correct. We can see it if it happens in water. And some gases are not colorless. Some gases have a color to them. So you may actually see the gas being given off. Another way, though, would be to smell it. Okay? So think about all those things. An unexpected color change. Now, why do we say unexpected? What happens if you mix red food coloring in water?
The one.
The water turns red. That's not a chemical change. It's not an unexpected change. What happens if you mix blue and yellow water together?
Green.
It turns green. It turns green. Not an unexpected color change, ladies and gentlemen. Okay? But if you take 2 clear solutions and it turns a bright orange, 2 clear solutions turn black. That is an unexpected color change. That is a sign that a chemical change has taken place. And then a precipitate might form. A precipitate is a solid that will settle out of solution. So a solid will be made and it will go normally to the bottom of the container. Some of them are less dense than water, though, and might float. But it will literally separate out either to the top or to the bottom of the container. Those are signs of a chemical change. So how would we know when a physical change has taken place?
It's different.
Phase change.
Okay? A phase change is a physical change. But how do we know when a physical change has occurred?
Just look at it. Observation.
What do we look for?
The signs.
What signs?
Like what state it's in.
What if it doesn't change states?
I don't know, you're screwed, I guess.
No, you're not. What are the two kinds of changes that there can be?
Yeah, physical and chemical.
Physical and chemical.
Yeah.
These are signs of a.
Oh, so if it's not one of those.
So if it's any of
It's
it's
not
not
So if it's not any of
so if it's
these,
not any of those, it's a physical.
if it changes but none of these things happen, then it's a physical change. So if it's a change but there's no change in energy, if there's a change and there's no gas release, if there's a change and there's no unexpected color change, if there's a change and no precipitate forms, it must have been a physical change because it can't be a chemical. So the same things we use to identify a chemical change, the lack of those things indicates a physical change. Make sense?
So adding food color to the water, expecting that color, that's a physical change?
Yes, correct. That is a physical change. Why? Because you haven't created anything new there. You've just dyed the water. Okay? That's a physical change. Okay? If you take two clear solutions and they turn bright orange, that's because something new was created, something that wasn't there. That's a chemical change.
Wait, so am I physically or chemically changing?
In what way?
Every way.
You got to be more specific because both are happening in your body right now.
That's all I needed.
Okay? Both are actually happening. Okay? Questions? All right. So let's get back to our lab and let's talk about what you're going to do today. All right. So you're going to obtain 2 to 3 grams of copper 2 chloride, ladies and gentlemen. Hey, at each lab station in the back, there is a container like this that has 2 to 3 grams of copper chloride in it. You are going to make at least 3 observations of the copper chloride. Now, you could touch it, you could smell it, you can look at it, you can listen to it. If it's talking to you, please let me know. Okay? Do not taste it. It is not good for you. Okay? Copper is a heavy metal. It is not good to ingest heavy metals.
I love that.
The same way, too, if you do touch it and you feel it, fine, but please wash your hands before you leave the lab. Okay? So, you're going to take and you're going to make observations of it. You are going to take a second graduated cylinder and put 25 to 30 milliliters of water in it. The markings on this graduated cylinder are good enough to use because this is an approximate amount of water. It doesn't have to be very precise. We don't need a graduated cylinder. By the way, make observations of the water. Okay? 3 to 4 observations of the water. Again, you can touch it, you can smell it. By the way, if you smell something and there is no odor, is that an observation? Yes. Odorless is an observation. Okay? Then you are going to take and you are going to mix the water and the copper chloride by adding the water to the copper chloride. It is easier to do that because you will get all of the water out of this container. You will not get all of the copper chloride out of this container if you try to pour it into the water. So after you add the water to it, you can simply swirl it around and record observations. This is the first spot, step number 3, where you are going to find a change. You need to figure out which one is happening. Is it a chemical change or a physical change? Okay? By the way, down here is where you will record what happens when you add water to the copper chloride. You need at least 3 things, could be up to 4. Okay? So step 3, when you add these together, you're going to record what happens. Now, please keep in mind, I will put the signs of a chemical change back up. But those are the things that you're looking for. Is there a change in energy? Is there a gas being released? Is there an unexpected color change? Is a precipitate forming? Okay? Now remember, a precipitate goes to the bottom and settles out. If some of that doesn't dissolve, is that a precipitate forming?
Yes.
No.
Oh.
If it either, listen, let me rephrase that. If any of it dissolves, that means that it will dissolve. But you could have too much copper chloride in there for all of it to dissolve. So a precipitate, either none of it will dissolve or most or all of it will dissolve. It doesn't go and sit at the bottom some, okay? You're going to get a piece of aluminum foil and you're going to make observations of it. So at your station, there is a piece of aluminum foil that looks like this, okay? In step 5, you're going to loosely roll the aluminum foil. What I mean by loosely is something like this, okay? Something like this. Don't twist it real tight, Step 5 is another point where you have made a change. You have to decide if that is a physical or a chemical change. Step 6, you are now going to take and stir the copper 2 chloride solution with the aluminum foil. So you're going to put it in there, you're going to stir it around for a minute or so, and you're going to let it sit in there. You're going to let it sit in there for about 5 minutes, stirring it occasionally. Okay? Stirring it occasionally. Okay? You're going to make observations for the next 5 minutes. They go down here. All of the waste for this lab cannot go down the drain. There is a container in the middle behind the box with goggles on top of the little counter there that has the waste for this lab in it. Take your aluminum foil, throw it in there, swirl this around, and dump it quickly. You want to empty this out as much as possible. And if you don't swirl it around, stuff will stay in the bottom and it will not go into the waste container. If you have stuff that is still sitting in the bottom, you simply take, and there is a wash bottle there, add a little bit more water, swirl it around and dump it quickly. If you don't dump it quickly, it'll stay in your container. Once you have almost everything out of here, then you can take it to a sink and wash it. Wash this, wash the other container, throw all your waste away, come back to your labs or your seat, write a conclusion explaining if steps 3, 5, and 6 are chemical changes or physical changes and why you think it is so. Questions? Go get the lab done. Put your goggles on, ladies and gentlemen. If you don't have goggles, come up to me and get a pair. Take a pair if you would like. Take a marker if you would like. Miro's hogging the red one, but
Listen,
all right,
you
so
could have
leave.
given guy back. That's not my issue.
yeah, and yellow.
Holy cow. I'm sorry, can you leave, please?
Finley.
I'm sorry, can you go away?
Wow, you are a member of the welcoming committee here.
The green one.
Jacqueline, you're getting a pair. Aiden. Aiden, where are you?
Hey, I have a question. Could you go slow?
Yeah.
Christian.
Thank you.
You're so welcome.
Thank you.
Yeah. Took you long enough.
Cynthia.
And audio.
What? Who are you working with first?
Um,
Find who you're working with. Let them know. Are you buying a pair of goggles for me?
yeah.
Okay.
Glad to know I look great.
Yeah.
But you have a physical reaction.
All
I
right.
know. I know.
What color you want? Write your name on it. Black. There you go. What color do you want? Red or blue? Red. Take red. What color do you want? Blue or blue?
My hair is long.
Here, take blue.
You're right, I like blue.
Okay. She
Actually, no, I want
wanted
black. My favorite color is black.
more information than I needed to know. I don't care what your favorite color is.
Well, now you know. My second
But I
favorite
don't
color is-
care.
Okay.
What's that? All the good people were born in August.
Exactly. Sorry, hating on me.
You're biased. You
I'm not
can't
hating
take
on you. I'm saying all the good people were born in August.
So I'm a good person.
Yeah, you just don't do things the way you're supposed to all the time.
Can I write my name like right here? Can I work alone?
You can for this lab, that would be fine. You can, okay, you can put your full name down, just your first name, I don't care. All you gotta do is find them in the box. Cynthia, you need to do me a favor. Go stand right there.
Why? I want to see this.
Cynthia.
What?
Go stand right there. Right there,
Can you type?
right there.
Of course, my computer.
Now, run real fast at me.
No.
Cynthia, you know,
That'd be
that's,
you hitting
you know
me.
that's
You're in my way,
insubordination.
so you would hit me.
You know that's insubordination, right?
You look
Not
yellow.
doing what a teacher tells you.
No, it's not.
Yes, that's the
That'd be
definition
you-
of
That would be you
insubordination.
hitting me because I'm walking and you're in my way. So
Right,
that'd
because
be-
the world needs to get out of Cynthia's way.
Yeah, exactly. For real.
Here are your signs of a chemical change if you need them, ladies and gentlemen.
I still don't.
No, I'm not gonna eat it.
Well, they say we can't sell.
Daniela, well, I would encourage her to do it as well.
Are you serious?
I would encourage her to. Hey, Cynthia, guess what?
Please, I'm working on it.
Guess what? Goggles don't do you any good when they're in your hands or on the table or on your forehead.
Why do we need glasses for this? Like,
This dissolve. Your head no. You tell me. Well, okay. Dissolving is a physical change, correct? So did any signs of a chemical change occur while you were doing that? If not, okay. Really, can I ask you to take your drink bowl and leave it at your counter?
Oh my god, I
We're back in the lab. Okay?
I didn't even know I had.
Nope, that's fine. We're in the lab. Well, again, remember, it's not all about the body. Okay? The only thing that is got apart, right, is some of it is all, but there's also things that are not. That it was just there and there. Because it's not going to, all of it becomes dissolved, but it's not dissolved there. Okay? What's that? Yeah. But you need to put on your goggles first. Where are we trying to go? First of all, that's not people. That is made out of. Well, tin foil would be made out of tin. Aluminum foil is made out of. This hand used to be made out of tin as well. They're now made out of. Oh, no, they give me reoxidation. How does it feel? How does it smell? What does it look like? That's reoxidation right there. I'm not working with you. Guys, if you're looking for reobservation, touch, smell, and sight can give you reobservation. Yeah. If you're figuring things out, it won't be my fault. You read the instructions. No, that is the one thing you cannot do is taste it. You are absolutely correct there for 1 second. I mean, this time again. Did I say for once? I'm sorry. I am. You're never right, so it is. That's the way it's supposed to be. Right? Okay, but now here's the thing. Again, like we were talking with Levi, if some of it dissolves, that means it will dissolve. That means it cannot be a precipitate. Okay? Now, maybe not all of it because there's not enough water in there is dissolved, but if some of it will dissolve, that's not a precipitate. A precipitate would be something different than it's settle out at the bottom. Okay? That makes sense? You can if you want, but I don't know why you need to. Yes, very wrong. It's not Kool-Aid. It might be cool, but it's not Kool-Aid. Please make sure you are using multiple senses to make observations. Yes. Yeah, you just don't want it real tightly rolled. Otherwise, it will make it harder to see what you're supposed to see. Please remember, when you stir it for a minute or so, let it sit in there, stir it again, let it sit in there, make observations. Okay, so when you're all done, yes, throw it in that container there, roll it up, dump it fast, like you could. You can rinse it down, you can use a squirt bottle, just don't touch the insides of your container. And then once you dump that again, you should be clean enough that you can just go to the sink now, wash that out, dry it, and put it over here for me with your original one. Thank you. Is that dry? Is that dry? Why would you? I'm not your mom. I'm not doing your dishes for you. And you can't even think of the term you shouldn't be talking about. Well, they're two very different processes. Actually, they're almost the opposite. Very much awesome. I know. I know. We'll see how you like the next one better. Did you knock once?
No, I'm not.
Well, why not? Okay, did anyone hear her knock? Thank you. We're in the back of the room. That's a knock. That's not a knock. Let's go. Get to work. Yeah, why? Yes, you got it. Oh, right. Correct. You, and if you're writing about your instead of reading what faucet.
That's for Lisa.
No, there was extra space.
Where?
There was extra space. I saw that between you and her. Yes. And you ignored her, and she ignored you. And oh, your dad is moved to Ocean. No.
I don't know.
Not in
I
high
was
school.
like 5 days.
In college, only did this dissected.
Orange like the one that found that amazing problem in that.
I hope you just put the like the and behavior shit. Is that what's super easy?
Oh, yeah, the limits.
We named ours
He
Hamlin.
just does that. Is that super easy?
Why? Gave a pig an iconic
In the
name.
system of equations thing, I hope we
Are
don't.
you leaving those goggles here? Or you taking them with you?
You said that.
You're leaving it there. There's a box.
Wait, what was it?
Yes, but it'll only be there for about 20 minutes. Okay, ladies and gentlemen, so at this point, you're done with the lab. You should now be taking and writing your conclusion. Your conclusion should be something along the lines of step 3 was a blank change. Here's why. Now, you can justify it by either saying these things happened because it was a chemical change, or it was a physical change because these things did not happen. By the way, if you want to say that step this and this were both this kind of change because these things did or did not happen, I am fine with that, but you need to describe all 3 steps, 3, 5, and 6, as being either physical or chemical and give reasons why or why not. Yes. I have a charging brick. I apparently am out here. I'll have to go and check if there's one in the back. Here you go. If you touch things in the lab, it would be a good idea to wash your hands at this time. Why? Well, it is not dangerous for you to touch these things. It is dangerous for you to ingest them. And if you have them on your hands and then you go and eat a sandwich or a bag of chips or snacks or some kind, then that can enter into your system and become more dangerous than it would be to just touch it. Again, if you're leaving me your goggles, even if you didn't buy them from me, but you want to leave them so that they are here for the next time we need them, please make sure they go in the box there marked first hour. I will make sure they come out every time that we have a lab that we need goggles. And by the way, next week you'll be doing another lab where you will definitely need goggles. Again, you should turn in your lab before you leave today. There's no reason you should not get it done, ladies and gentlemen. Well, have a good weekend.
Mr. Brad
Yes.
is struggling with everything. I tried both sides too.
Well, I don't know what to tell you because it says it's fully charged. All I could say is bring your computer charged then. Sorry.
I know that my brother was using it last night.
All the
But
way
it's
till 5 o'clock or 6 o'clock this morning.
Well, I was gonna plug it in when I woke up. I forgot.
Ah. We'll try switching the cord around. Maybe that'll work for it. Please remember, ladies and gentlemen, you are going to your second hour class next. You are not going to home base. There is no home base today.
It isn't early release.
Yes, you're getting done at 12:25. If you stay for lunch, 12:50. Yep, today is an early release day, ladies and gentlemen.
Why didn't they tell us this earlier?
They announced it at 5:15 this morning.
Yeah, they sent out an email.
They put it on the news. They put it on the
Oh, never mind. I saw that.
yeah. Have a great weekend, ladies and gentlemen. Be ready for your quiz on Monday. Goodbye, goodbye, goodbye. Tuesday, sorry, thank you. Good call. Quiz on classification of matter and heat and temperature. KMT. Don't forget your phone. Go away, get out. Come on, I can't get you guys to come here. Now you won't leave. Go away. Go away.
Empty.
Is this
Jeez, you're
recycling?
still here. Go away.
Is this recycling?
That's a can of something. Go away.
Students, just a reminder that you should be heading to your second hour class.
Second hour.
That's your second hour.
Go to your second hour class.